Good evening, everyone. Very good evening. Okay, guys. So, what did we do in the last class? Can anyone tell me? Why is this breaking? Is my voice breaking? All of you, let me know. Is my voice breaking for all of you? class name at hexadecimal value. This is how you will be getting. So why are you getting like this? Whenever you are printing the reference variable, why are you getting the address of that object? Okay, why are you getting the address of the object? Because in every class, remember, all class extends object class. All class extends object class. When it is extending object class, all 11 non-static methods will be present inside this class. All 11 non-static methods will be present inside this class. So that is why here when you are printing the variable d, your toString is present. ToString is implemented in such a way that if you are printing the reference variable, it has to show the address of the object. Okay, toString is implemented in object class in such that, okay, such that whenever you're printing the reference variable of an object, okay, in any class you do, because every class extends object. So in every class, if you're printing the reference variable, surely you will be getting a address. That is, if package name is the package name, or in just a default package if you have created, you'll be getting class name class name at hexadecimal value. Class name at hexadecimal value. Okay, so this is how you will be getting your address printed if you're going for object creation. Okay, so let us go for one package. Okay, let us go for a package called as, let us go for Eclipse first. Okay, so where do we have here? E23. Okay, so in a default package we shall go. Okay, let us create one package. We'll just create object class programs. Okay, object class programs. So currently we are in a object class programs. Where is it? Oh, okay. We have created a class. No, we have to create a package. Let me delete this. Okay, src, we shall go for a package and we'll go for object class programs. Object class programs. Okay, now so here let us create one class. Okay, now let us create one class. So that class name we will take it as a demo. Okay, that class name will take it as a demo. Now currently in this class we don't have main method. So what we will do, we will create one main method. We do have a main method here, right? Now let us create an object for this class demo. Demo d is equal to new demo of no argument constructor. Now if you are printing variable d, okay, variable d, if you're printing, you'll be getting output in the form of package name dot class name at hexadecimal value. Hexadecimal means it's a combination of numbers and alphabets. Okay, let me show you the output now. So can you see, you're having a package name dot class name at hexadecimal value. Package name dot class name at hexadecimal value. Okay, this is how you'll be getting it. Okay, am I audible to you all? Guys, am I audible, everyone? Let me know if I'm audible. Okay. Okay, guys, fine. What is the topic? Topic is object class. Okay. So here, one second. Okay, guys, sure. I had an issue with login. Okay, that has been sorted out today because there was holiday all these days. So Okay, so I was not able to log in. I contacted them and today they have solved. Okay. Okay, so what is the issue here? So here every class, if you take every class extends object class. Every class extends object class. It's whether it's an inbuilt or a user defined. Inbuilt or user defined, both of them inherits object class. So when it is inheriting object class, obviously the 11 non-static members also will be inherited into the class. Now currently inside this class, we have 11 non-static method. In that first one we have seen, that is our toString. Okay, so why we have to learn about toString is, very simple, very simple. Whenever you are printing the variable, okay, reference variable, here you are getting, okay, you are getting address of the object, which is even not true. Okay, which is even not true. So this address is a fake address. This address is a fake address. Okay, though it is a fake, then why are we knowing about that? See, nowhere we use this address. Nowhere we will be using this address, but still we need to know how the address will be there. Okay, how address will be appearing. How address will be appearing by this overriding two string. I mean, by this implementation of two string only, we'll come to know. Okay, every class. Okay, every class has, okay, every class has reference variable. Like if you have created an object, and every class will have an address, so this object will also have an address, and that object address you are seeing here, package name dot class name at hexadecimal value. This is even not true. Okay, our Java will never provide a exact address of the object. Okay, Java will never ever provide the exact address of the object. This is a fake address. Our Java is provided as the fake address. Though it has provided this fake address, it is very secure. Okay, it's secure. So that is why we'll be able to tell that our Java is secure and easily it can't be hacked. Okay, so here, how will we get the clear? No, you will never get the clear address of the object. You will never get. That is what, no, it is very secure. You will never get. Never ever you get. In a random address it will be stored. Okay, we'll never get to know the address. Okay, so here this is the problem. Okay, this is the problem. Whenever you print the reference variable, you are getting the address of the object. You are getting the address of the object. Okay, let it be. Okay, this our, I mean, actually Java doesn't provide a real address of an object. So whenever programmer types, tries to print the reference variable, toString is implicitly called. Okay, remember, whenever a programmer tries to print the reference variable, whenever a programmer tries to print the reference variable, toString is implicitly called. toString is toString is implicitly called. Okay, now suppose let us take one more class. Okay, let us take that class name as a circle. Okay, it's going into polymorphism. Wait a second. Oh, this also we have created in polymorphism. No. Where are we? Object class program. Let us create one class under this. Let us go for a class named circle. Okay. In this class circle, listen carefully. In this class circle, now, now let us take the radius of the circle. Circle will have a radius, diameter, right? So we'll take radius in int radius. Okay, and as a circle will be, for a class circle we'll be creating one constructor int radius. This dot radius is equal to radius. Okay, now we have created a constructor for the class circle. We have created a constructor for the class circle. So this dot radius is equal to radius. Done. Initialize the object. Yes, see, what is our problem is, whenever we try to print the reference variable, our toString method is implicitly called. When it is implicitly called, it is printing the address. When it is implicitly called, when it is implicitly called, it is printing the address. So because of this, what we'll do here also, now let us take main method. Here also you'll get to know. Okay, one second guys. Excuse me guys. Okay, so here what we are doing is, okay, see here, whenever we try to print the reference variable for the circle object, I'm repeating again, listen carefully. Circle C is equal to new circle of, okay, data here is, okay, circle data, we can go for data 5. Okay, so here circle C is equal to new circle of 5 here. Now what is this? This is a constructor and we have a data here. Okay, fine. Now let us try to print the reference variable. That is C. Now if you print the reference variable here, you will be getting address neatly. Now can you see? Can you see the address? Object class programs dot circle class name at hexadecimal value. Object class programs dot circle at hexadecimal value. This is how you will be getting the output. This is how you will be getting the output. Since we are getting like this, whenever we are printing the reference variable of an object, whenever we are trying to print the reference variable object of an object, we are getting the fake address of the object. You'll never get the original address, you'll get fake address only. Now since we are getting a address, now we don't want it. Since it's fake, there is no use of it. Since it's fake, there is no use of it. So here we will not be printing the address. Instead what we will do is, guys, once again, excuse me guys, some background noise, excuse me. Okay, so here the problem is we don't want this address. The problem is we don't want this address. What we want is, instead of address, we will be going for printing the data. Okay, we have, because we are getting address, we don't want. Instead of that, we can override that method, toString method, and we can return the state or the data of an object instead of returning the address. Instead of returning the address like this to the in the output, because toString is implicitly called when we print the reference variable, let us override toString. Okay, let us try to override the toString in such a way that when you're printing the reference variable, instead of getting the address, we shall get the data. Instead of getting the address, we shall get the data. Okay, so here now what we'll do is, we have to override toString method. Okay, we have to override toString method. Now how can we override toString method here? Very simple. We'll go for the annotation at override. Now we shall go for a toString method, public string toString method. And here, as you know, here return type is a string. Return type is a string. So we have taken return type as a string. Now what we have to do is, we have to return data in the form of string. We have to return the data in the form of string. Okay, so how can we return? We have to go for return keyword, return radius. Okay, whatever it is, and we'll go for radius variable. Okay, in this way we are returning the radius of the object. We are returning the radius of the circle object. So now if you print the variable C, now instead of getting the address, okay, now you'll be getting the data or the state of the object. Can you see here, instead of address you got radius 5 centimeter. Let us add centimeter also. Okay, so we'll go for 5 centimeter. Okay, so as you can see now, by overriding toString. By overriding toString, this inbuilt method toString in the object class, we are changing the implementation. We are changing the implementation. Implementation means we are changing the data between these blocks. Data between this method block we are changing. So here we are returning the data. Okay, instead of returning address, we can return the data here. So we are returning radius, whatever the data radius is there, that much centimeter we are returning. Okay, so this is the use of toString method. This is the use of overriding toString. This is the use of overriding toString method. Okay, so this is for one object. Okay, this is for one object. If you create multiple objects also, same thing will happen. Okay, how many ever multiple objects you create, okay, how many ever multiple objects you create, it is the same. So what happened here, we have created a circle object and radius for the circle. We have created a constructor for the circle and we have initialized the radius. So in the main method, we have created a circle here and we are printing, we have created object for circle there and data 5 we have given here and we are printing the reference variable C. We are printing the reference variable C. Now after that, whenever we are printing the reference variable, we used to get the address, because whenever we print the variable C, the toString method would be implicitly called. ToString method would be implicitly called. But here, since we are overriding ToString, we have to take the ToString method here and we are changing the implementation. Earlier implementation was in such a way that it was whenever we printed the reference variable, it used to give the address. But now we have changed the implementation to return the data. Now we have changed that implementation to return that data. Okay, so this is why we will be going for overriding toString method. This is why we will be going for overriding toString method. Okay, so this is one object. Okay, now let us go for one more example. Let us take class student. Take class student, and here in the class student here, okay, so we shall go for attributes of the student. Minimum we will take two attributes. We shall take student name and student sid. So student name string is name and we'll go for int sid. Next we shall go for the constructor of the student. So source, generate constructors using fields, generate, right? Now why did we get supercall statement? What did we get? See, your class is extending no class, right? But why did we get supercall statement? We got supercall statement because internally every class is extending object class. Internally every class is extending object class. Since our student class is also extending object class here, you are calling using supercall statement, you are calling object class constructor, that is object of no argument constructor, you are calling using super of no argument constructor, and we are initializing the members of the student. Done. Now let us go for main method. After this we shall go for creating multiple objects of student. Student s1 is equal to new student of now. So we shall give Manu student name and student id 1. Next student s2 is equal to new student of Anu SID, that is 2. Next third object, student s3 is equal to new student of Sonu, id will go for 3. Next student student s4 is equal to student s4 is equal to, we shall go for instance, that is new student of new student of Tanu, Manu, Danu. Okay, so minimum 4 students we have taken. Minimum 4 students we have taken. If you go for printing all the reference variable, so let us try to print the reference variable here. So within double quotes, first let us print the first one. So first one will go for s1. Next slash n will take you to the next line. Okay, s2, s3, s4. Okay, now if you execute, you will be seeing only the addresses of the student object. You will only see addresses of the student object. Yes. Okay, so you will be seeing only addresses of student object. Since you are getting only the address of student object, it's not valid. You don't have to get address because it's not a real address, it's a fake address. It's a fake address, so we don't have any use of it. So what we shall do is, okay, what we shall do is very, very, very simple. We shall go for overriding toString. So we'll go for annotation at override, and we'll go for toString method public string to string method, and here we will be returning okay, implementation. So first student name colon will be going for yes name. Okay, and after that in the next line or in the same line we can take, next will be going for, okay, student id, that is we'll go for sid. Okay, next we'll go for semicolon. Okay, we'll go for semicolon. Now we have overridden toString here. Why? Because instead of getting the addresses here, okay, we shall get the data of 5 objects. Okay, so here all the data of 4 objects, all the data of 4 objects now we'll be getting. If you go for this, implementing this toString method. Okay, here you will be getting student name, whatever the name we have given, and student id will be getting that sid. Okay, now if we execute, for every object separately you will get a student name and student id. Now can you see here, everyone? Can you see here? Are you getting student id and student name for every object? See, firecracking voice because the Ganesh has been kept. Okay, it's coming from far, but it's still you're able to get it. You can override only when there is a same method, right? What? You can override only when there is a same method. No, when there is a same object. Yes, only through overriding toString you will be getting the output. Why we have to override toString? The main reason is one. Okay, if you are getting, can you see this output? Student name Manu, student id 1, student name Tanu, student id 2, student name Sonu, student id 3, student name Danu, student id 4. Now why you are getting this? Who is responsible for giving the output when it is when you are printing the reference variable? When you are printing reference variable, if you are getting, okay, the address of the object, then it's because of your toString. ToString is implicitly called. That is the problem of toString. So what we have to do, we have to implement in toString itself. We have to implement in toString itself. See, in every method we can create what kind of method we want, we can create. But here, how many times ever we print the reference variable? If you want to get the same implementation, we have to write this implementation in your toString method. Okay, only overriding toString method, whatever or how many ever objects you create, okay, if you print those reference variables, you will be getting this implementation of object like this. Okay, you'll be getting implementation of object like this. Okay. Okay, so here, okay, you guys got it, everyone? Everybody got it? How can we get this data by other logic also? Then what is the need to store in what we will use real time? Wait. See, why in real time, what is the use of to string concept? Okay, see here, whenever we are printing the reference variable, see other methods also you can create. Okay, other methods also you can create. How? You can go for public string, just get a string method. Just like that, you can create and you can return the data. Actually, return, same thing will give. Okay, same thing will give. Okay, now we shall make this method num. Okay, now currently we have only get string method. Now what we will do, we will call it here. Okay, which whom we are calling? Suppose if you call s4 dot uh, get string method. Okay, now let's execute. So what are we getting here? Okay, since you are returning, we'll be going for printing statement. Let us execute this. Now, can you see? Can you see a student name? Danu ID for only for object 4 you are getting. Only for object 4 you are getting. In case if you want to get for all the objects separately, you have to print s1 dot get string, s2 dot get string, s3 dot get string. It's not a proper way. Okay, this is also possible, but this is not an inbuilt method. This is not inbuilt method. And if you remove this, okay, if you remove this, if you don't call, okay, if you don't call, still it should be called. If you don't call, if you're printing only the reference variable, if you're printing only the reference variable, it should be called. It should be called, but it is not called. Because why? It is a normal method. It's not a two string method. It's not a normal method, it's a two string method. Okay, so whenever we printing the reference variable of an object, okay, we will be finding the, we'll be getting the data. Okay, we'll be getting the data or state of an object. So this is the need of using your overriding two string method. Okay, I hope you guys understood now. Everybody got it? Yes sir, Himanshu. And yes, Lipsa, only by overriding we will get this. Okay, anybody else? Sanket, don't worry, man. I was having issues with the login, so I couldn't send. Ma'am, in a two string method, which type of data type we take? See here, since we are having a return type as a two string, return type two string we have taken, you can return whatever type of element you want. See, in string concatenation is possible. Concatenation is possible in two string. Take string, take string, along with that, give anything. It will take. First you have to take a string. See, suppose if you are mentioning string as a return type, first you have to give string. Okay, you have to give string first. After that, give how much ever data, and whatever data you give, it will take. The thing is, you have to return only the string type. You have to return only the string type. Okay, so this is how your two string goes. Okay, okay, I hope you guys have understood. Okay, now Since you are overriding toString, we are not calling this toString method because it is implicitly called while printing the reference variables of an object. And now you'll be getting neat output of all the object. Okay, all the object along with the reference variable, you are getting it. Okay, so this is how we will override this is how we will override your toString method. Okay, next. Okay, I hope you guys have understood toString. Now let us go for your equals method. Any doubts in toString, guys? Anywhere, any doubts you have, you can let me know. Okay, now let us go for your equals method. Already we have taken two programs. In circle, we have taken any real-time example. Yes, in real time, when we do projects, you'll get to know. When you do projects, if you just print the reference variable instead of see, suppose you have not created any special methods for taking all the data of your or attributes of your object. If you just implement the toString and without calling that, okay, if you just print the reference variable, it's very easy work, right? Instead of creating the whole method to print the details of an object, okay, every time you have to call, every time we create an object you have to call. Okay, I'll just tell you what is the uses of this toString now. Just a minute. See here, suppose if you're doing one big project, okay, in projects also we'll use in upcoming classes. Now assume you have created one big project. Now in that project, so you are creating multiple objects: object 1, object 2, object 3, object 4, and you don't want to call the method again and again. But if you're printing the reference variable 1, reference variable 2, reference variable 3 of the object, reference variable 4 of the object, so printing the object references. Okay, you're printing object references, but you're not calling any method. You don't have to call any method, because if you're overriding toString in that class, in that object class, if I mean in whatever the class you're in, there if you overridden toString, how many times you print the references by creating the object, you will get the same type of output. You'll be getting the same type of output. Okay, in a projects also we'll be overriding toString equals and hash code. Okay, so this is the use of your toString. You don't have to create any special method, like suppose if you create a car class, you'll go for car details method. You don't have to do it. Just take toString method, just implement all of the data. Okay, whatever the thing is there for every object, toString will be called. Okay, for every object creation, toString will be called when you're printing the reference variable. Okay, so this is the practical use of your toString method. Okay, hope you guys got it. Instead of just calling the methods every time, we just print the variables, reference variable, we get the output. How override is working? See, overriding is working in a format that, see, without this also it will work. This is just a annotation. Okay, this is just a annotation here. Here overriding means what? Can anyone tell me what is method overriding? Can anyone tell me what is method overriding? Because we have seen in last class. If you remember, tell me. Anybody? What is method overriding in runtime polymorphism? We have seen. Same method with same signature. Okay. From where? From which class? From which class to which class, or inside the same class? Method overriding. Non-static method only. Same method signature, parent and child. Yes. But overriding means what? Overriding. Everything is correct. But overriding means what exactly? Yes, is a relation should be there. Okay, I'm gonna tell you guys again. So how overriding is working is, in the object class, in the class object, you have toString method. You have toString method in the object class, and you are creating one class called as student. Okay, the student class is inheriting this object class members. 11 non-static methods already inherited because every class extends object. Every class extends object class. We know that. Okay. Now, while inheriting, suppose if you print in this class, suppose if you print any variable, reference variable, surely we'll get address of it. So instead of getting address, we are overriding here public string to string method. Okay, and we are changing the implementation. Here also public string to string is there, but implementation is different in this object class. Okay, in this object class to this to string method there is a different implementation, but what we are doing in the student class is we are overriding that method. Overriding means parent class and child class, if they're having is a relationship, parent class and child class should have same method with same signature, but overriding means changing the implementation of the parent class method, changing the implementation of the, that is whatever is there within the block. Okay, you have to change the implementation. Okay, methods will be inherited by sure, by default it will be inherited, but you are changing the implementation of that method. Okay, or the task of that method, whatever is there in the body of that method you are changing. This is called as method overriding in runtime polymorphism. Okay, the same thing we have done here. Same thing we have done here. In the object class, there is a two-string method with a different implementation. Means different in the method body, we have different code written. But here we are changing that and we are making it to our comfort. We are making it in such a way that it should be very beneficial to us. How? By returning the proper data or the state of an object. Okay. So can you guys tell me now? Is it beneficial or not? Is it beneficial? Is it beneficial or not? We are just overriding two string. Yes or no? Is it beneficial or not? Yes, it is beneficial. Correct. Okay. Okay. Now let us come to class student. Okay. Let us come to class student. Now, what I will do is I will check the data of each object. We check the data of each object. Okay, fine. Now, data of each object is different. Data of each object is different. Yes. Data of each object is different. Yes. Okay. Now I have to check, just it doesn't matter which address the object is. Okay, where the object is present, or if it is same, if the data is present in same object or the data is present in different object. Now I will start comparing this data. Okay, I'll just try to start comparing data using your equals method. Okay, so in order to compare the data irrespective of from which object it is, irrespective of from which object it is, now we'll try to compare the data of the object. We'll try to compare data of the object. Okay, so what we'll do is for doing this we have to go for a equals method. So the full name of equals method is public boolean equals of object O, equals of object O. So here you'll be writing an implementation. Okay, here you'll be writing an implementation for the equals method in such a way that, okay, instead of just excuse me, instead of just comparing, instead of just just having so many objects, we'll just try to compare the data of each object. Okay, so we'll just try to compare the data of each object, and now let us see how we can compare the data of each object. See, irrespective of which object it is from, see, in big applications, if you click on details of a person or your details, assume whatever, it's a found date or maybe Naukri or whatever it is, qtalk application, if you take, if you just click on details, can you see all your details? If you click on details option, can you see all your details, right? Yes, that is possible with the toString. Okay, that is possible with the help of normal methods also, but in a code we have to always call that normal method. But instead of calling also, see, no, you are not the only student, right? Many students are doing it. So in order to it doesn't matter how many students will be there, but the code has to be equally working for everyone. So two string, in the two string will be going, I mean in the two string method will be implementing in such a way that if you're printing s1, we have to get the data. But to check if the two objects are having two or more, okay, minimum two, if to check if the two objects are having same data, okay, to check if the two objects are having same data, we will be going for equals method. It's like you're taking the details of yours and you're taking the details of other person and you're checking it. Okay, now we have to find out the similar data. Okay, so here two string we will override, I mean equals we will override, equals method we will override. Okay, to check or compare the reference of two objects. So here what happens, equals method before overriding, it will be working as a equal to equal to operator. So let me tell you fully here now. Okay, so your equals method, okay, 1 second. Okay, see here, equals of object o, equals of object o. Now here the return type of this equals of object o is boolean. Okay, and equals method, we can pass the reference of any object in the place here. To the object address we can pass the address of, I mean we can pass the object of any address, I mean we can pass the address of any object. Okay, so this equals method is also present in java.lang package. And this equals method currently now it is used to compare the reference of two objects. Compare the reference of two objects. See, we were planning to compare the data of two objects, right? But without overriding, your equals method behaves as comparing the references or addresses of two objects. Okay, so now here, okay, let us take one book object and let us understand it. Okay, let us take one book object. Let us take a class book. Okay, so let us take the class book here. So book will have a book name. Okay, string book name, that is b name. Okay, now let us go for object creation. Book of string book name, and we'll initialize the this dot book name is equal to book name. Now after this, now we shall go for main method. Okay, now after going for main method here, okay, now what we will do, okay, now what we will do, we can go for equals, but first we have to go for object creation of the book. Book b is equal to new book of, now book name will give Harry Potter. Okay, we'll give Harry Potter as a book name. This is one object. If you take book b1, which is one object, I will go for creating one more book. Book b2 is equal to new book of, we'll go for Harry Potter. Okay, then we'll go for Java. Okay, now we'll go for book b3 is equal to new book of, again we'll go for Java. Okay, now listen carefully. You guys know what equal to operator does. Double equal to operator, you know it will compare LHS and RHS, right? Now what we will do is, okay, we will try to compare the data, I mean the reference variables. First we'll try to compare the reference variable. Okay, so the println statement will go for b1 equal to b2. So b1 equal to b2. See, this is a different object address and b2 is a different object address. Okay, because of new keywords, every new keywords is a different object. Every new keyword creates a different memory block. Every new keyword Every new keyword creates a different memory block, creates a different memory block. Okay, so here b1 equal to b2, so we are comparing the address. So since b1 and b2 are different objects, you will be getting false. LHS is not matching with the RHS, you will be getting false. Correct? Yes. Now let us take uh, b1 b1 with the b3. Now also you'll get false because the addresses are different. Now also you'll get false. See here, now also you'll get false because the addresses are different. Again, now we'll be going for, so b2 with the b3. b2 equal to b3. Since the data is same, okay, though the data is same, if you execute still, because it's a different object, both are different objects, still you will be getting false. Still you will be getting false. Okay. Now here equal to operator is doing that work. Equal to operator is doing one work. The same work your equals of object also is doing. Equals method is also doing the same. Equals method is also doing the same. What task it is doing? Okay, what task it is doing? So we will learn it, but before that we will override toString here. So we have not overridden toString. So we'll override. So public string toString method, and we will return student name. Go for double quotes. Student name, whatever the name we have given. Sorry, book name, right? So book name. We'll go for rename variable. Okay. Suppose, okay, equal to operator is comparing the addresses of each object. Okay, fine. Now if you print, okay, b1, b2, b3, now you'll be getting a different data. Okay, so b1, okay, b2, okay, next we'll go for b3. Okay, see b1, b2, b3 contains different data. Since our toString is already overridden, you will be getting book name Harry Potter, book name Java, book name again Java, book name Harry Potter, book name Java, and again book name Java you'll be getting. So why will be getting Harry Potter, Java, and Java? Why will be getting like that? Because your toString method is overridden. Since the toString method is overridden here, you will be getting the data here. Okay, let me show you. Okay, wait a second. Can you see here? Book name Harry Potter, book name Java, book name Java. Oh, okay, fine. Now, instead of equal to operator, we will go for equals of object. Okay, we'll go for equals method. So how can we go for, as we told, in equals method, equals of object reference. So in the place of the object or the reference, we can replace with any reference. So b1 dot equals of object b3. Okay, b1 dot object of b3, or we'll go for b2, b1 and b2. Now, see equals of b1 and b2. See, currently we have not overridden equals method. We have not overridden equals method. We have not overridden equals method, but we are trying to compare the b1 reference and b2 reference. Okay, b1 and b2 we are trying to compare. So let us execute. Still you will be getting false. Why? See, you are still getting false. Why? Because without overriding equals method behaves as equal to operator. Without overriding equals method behaves as equal to operator. See, there is no difference between equals method and this double equal to operator. Currently there is no difference. So what we have to do here is we have to override your toString, sorry, equals. Okay, so why you have to override equals? Because we have to know if any object data is matching. See, whenever you are suppose somebody has placed, okay, somebody has placed, you both will have, suppose if you take puja. Now puja and puja, there are two pujas, there are two pujas with same name. Okay, just pujas only, there one person is puja and one more person is puja. Now we are checking if the same person's name is there. We'll search for puja, but we got two objects. Why? Because your equals method is overridden. When we are searching for same method, okay, same name objects. That means currently, if your HRs are searching for a name puja, they will be getting how many other names are there with the puja. Everything they'll get. Okay, everything they'll get. Why? Because your equals method is overridden. Now currently equals method is not overridden, so that is why when you are going for variable b1 dot b2 equals, if you are doing, you are getting the false. Currently there is no difference between equals method and double equals to. So what we have to do is we have to override equals method in such a way that it should compare the data. It should compare the data or the state of an object. Okay, it should compare the data of an object. So how can we do? How can we override? You don't have to mention again override, but I'm mentioning here because we'll be overriding equals. Override. Now, full method name for the equals method is public boolean equals of object. Oh, now, now listen everyone, correctly listen. Okay, so here, now listen carefully. Currently we are in the class book. Okay, currently we're in the class book. Now listen carefully everyone, see the screen. So we have a class object also, we have a class book also. Now listen carefully, you guys have to answer this question. Okay, only you guys have to answer this question. Listen carefully. Now, okay, assume we have an object that is, one second. Okay, assume we have a class object here. Listen carefully. Now we have class book here. Book is inheriting object. Okay, fine. Now, see, if you upcast, we know address will go to object, and now after upcasting, you can't downcast. You can't downcast. All the all the members are first of all, every class is upcasted. Every class extends object. Every class by default extends object class. Here, listen carefully. This object class is there, right? This object class. See, parent class can't access child class. Now, what parent class has to do in order to come and access the child class members? Suppose book name is there. Now, what object class should do to access this book name of the class book? Every class extends object. Okay, every class inherits object. So in order for the object class to access this or compare the data of the book, we have to go for downcasting. We have to go for, yes, correct, we have to go for downcasting. The same thing we'll be doing here. Currently we are taking the object class. We are in the object class currently. We have to downcast the object reference to book class first. We have to downcast. Why? Because object class should compare the data. Okay, it will be helpful in comparing the data. Okay, so what we will do here is we shall go for, okay, there are so many ways of doing it. So we shall first will downcast it. Book b is equal to, so reference book of the variable reference or reference variable o. So currently we are downcasting to book type. We are downcasting to book type. After we are comparing, okay, see, equals method we take, okay, to, we override equals method to compare the data of two objects instead of comparing the reference of two objects. Okay, equals method is, if equals method is not overridden, it will compare the object reference of two objects. But if equals method is overridden, the data of the two objects will be compared. Okay, the data of the two objects will be compared. If equals method compares the data of the current, I mean the equals method compares the data of current object with the past object by downcasting the past object, by downcasting the past object. Okay, so here now see here we'll be checking. Okay, we'll be going for return keyword, return. So this dot radius, oh, one second, book, no, book b name. This dot book name, this dot book name is equal to b dot book name. What we are doing here? What are we doing here? Very simple, very simple. We are going for checking the data of this dot b name means current object, b dot b name means past object. This dot b name, we are taking this dot b name and we are downcasting object to book class, and with the help of reference variable of book we are comparing, we are taking another data of the object. Okay, if equals method, it will, I mean your equals method compares the state of current object, that is using this keyword we can access currently executing object. So we are accessing current object and okay with the past object. Okay, with the past object we are checking if it is equal to or not. You can use equal to, or you can go for dot equals to, you can go for dot equals to b dot b name, dot equals to b dot b name, both are same. Okay, so here since we are trying to compare the data here, okay, see this dot b name dot equals of b dot b name. Now if you are using, equals, if the data of two objects, you forget this addresses of the object, you forget. Now see the data of the objects. Now is Harry Potter and Java data same? Yes guys, tell me, Harry Potter and Java data are matching? Harry Potter and Java data are they matching? No, right? Okay. So if it is not matching, since the return type is boolean here in the equals method, since the return type is boolean, we have to get false because they are not matching. They are not matching. Okay. So here we'll be getting to know that b1 dot equals of b2. Since Harry Potter and Java both are two different strings and they are not matching, so you'll be getting false. Are you getting false here? Yes, you are getting false. Okay, after that, now we shall compare, we shall compare the next one. Now we shall go for b1 dot c equals of b3. See, both are same. Once we have done with b2, we can do with b3 also, both are same. Now what we will do is we will take b2 and b3. So we'll be going for b2, we're going for b2 dot equals of b3. Now can you guess what will be the output here? Here Java and Java is same, it will be true. Yes, it will be true only. Since Java and Java both are same, here in the second one you will be getting true. Why equals method returns true? Because whatever the current object we have taken and whatever the past object we have taken, that is this dot b name dot b dot b name, okay, both are true. The data is same. So since the data is same, you are getting true here. Okay, so this is how you will be checking if the data of two objects are same or not. In real life, many places you will be using, okay, to fetch the data, fetch the details. Okay, so in core Java you can do this. Okay, but if you go to advances and all, you go for JD, your SQL and all. Okay, so currently you can fetch the data like this. So big designs will be doing. Okay, so the designs will be doing UML designs. There also will be implementing this. Okay, so this is why we'll be overriding toString. The main reason why we have to override toString here is we have to compare the data of two objects. If the data of two objects, irrespective of the reference, that is, just ignore the object references. Check the data of the object. Yes, downcasting is mandatory because here first object, okay, here who is currently object is comparing one name it is taking, and another name should be compared here. equals method, in equals method. Now currently here we compare the date of two objects, that is current object. Current object is taken as this dot b name, and with a past object here we will be passing the object. Here we will be passing the object. So to access this, first you can take any object here, but you have taken object class only, object o. You have to downcast here, and now it has been converted to book type. We can go for b dot, b dot b name. So we are taking current object dot equals of past object. Data of current object dot equals of past object. Can you see here? B2 dot equals of B3. B2 is the current object. B2, that is this dot B name. This currently it is B2. See, when this line is executing, when line number 27 is executing, B1 means this dot B name. Next, here B2 means B dot B name. Current object with a past object. Current object. See, can you guys, I know, right? This this keyword currently store the reference of, it store the reference of currently executing object address. This keyword will store the currently executing object address. You already know that, right? So current object address will be taken here. Now for comparing one more data, we need a one more object, right? We need one more object. So we have taken one object class only we have taken, and this is a standard way. Okay, this is a standard way we have taken, and we have downcasted to book type. So we are going for book dot b name. We are comparing current object with the past object. It's necessary to downcast, or else it is not possible to compare two data at a time. Okay, two data at a time we can't compare. Okay, so this is the uses of your overriding to string equals method. Okay, this is the advantage of overriding equals method. And remember, without overriding equals method behaves as a equal to operator. Don't forget that. Okay, without overriding equals method behaves as a equal to operator, only comparing the references or the addresses of the object. Before overriding, equals method will compare only the addresses of these objects. Okay, but now after overriding, it is comparing the data of the two objects. It is comparing the data of two objects. Okay, so I hope everybody got it. Everybody understood equals method? You guys got it? Guys, did you get it? Understood everyone? A bit, okay, if you practice it, you will get it. First time only, you don't have to get it, okay? Please take, yeah, I'm taking one more example. Circle C1, circle C2 is equal to new circle of 5. Not fully. Okay, for comparing, what you will do? What you will do for comparing? You will take two objects, right? See, guys, for comparing, what you will do? How you will compare? You will compare by taking one object. See, everything is taken as an object. Suppose take you have 5 chocolates in your hand, right hand, and there are 4 chocolates in the left hand. Now, if you compare, okay, can you tell both are same? Can you tell both are same? No, right? Yes. So when you're telling the chocolates are not same, then how come you're telling datas are same? No, you have not told. Yes. Here, okay, we have gone for book object, right? See, we are taking data of the object. Before overriding, equals method behaves as a equal to operator. See, equals method. So let us just nullify this. Let us not override this. Listen carefully. Once again, I'm doing this. So currently we are not overriding. Currently we are not overriding equals, and there is no difference between equal to and equals of object method. So same thing, b1 equal to b2, and here b2 equal to b3. Now you will see everything will be getting false only. Okay, because we have not overridden equals. Currently only we have class book name, constructor, toString overridden, fine. because if you're printing the address, you have to get the data of the object. Okay, now, so b1 equal to b3, we already know equals to operator compares with the LHS with the RHS. So b1 and b3 are the same? No, you'll be getting false. And b2 and b3 are the same? Equal to is comparing the addresses. Addresses it is comparing. So as of addresses it is false. And here whatever equal to operator is doing, equals method is also doing the same thing. Equals method is also doing the same thing. Okay, now you'll be getting false. Can you see all four falses you're getting? Why you are getting false? The first two false is because these three new objects have full three of different address. This, since we are having three new keywords, three different new keywords we have. Okay, so that is why you are having a three different objects here. So we have three different objects. Equal to operator, that is double equal to operator. This operator compares the LHS with the RHS. So B1 equal to B2. So what is there in B1? Address. B2 address. B3 address. So B1, B2, B3, if you are checking, see B1, B2, B1 equal to B2. Suppose if you take, okay, suppose if you take address as 0 x1 here, and if you are taking address as OX1 or OX2, whatever, OX2, and here 0x3, whatever. Now listen carefully. Now we are checking 0, OX1 equal to OX2. Now tell me, in the line number 27, what will you get? Will you get true or false? Equal to we are doing. LHS equal to RHS we are doing. We will get true or false? Obviously, we get false because addresses are different. In the same way, B2 equal to B3. So it is 0 OX2 equal to OX3. Okay, now tell me line number 28, what it will give? Yes, obviously false only, right? When the object addresses are false, you can't tell objects are same, right? This is the logic. Object addresses are false. This equals method, with before overriding, it will do the same thing. That is here 0 or OX1 dot equals of OX2. One second. We'll make it as a big here. Okay, OX2. Now 0x1 dot equals of OX2. See, equals method is not overridden. Currently, equals method compares the address. Is the address same? No, address is not same here. Now let us check here. Same thing. OX2 dot equals of OX3. Okay, now can you guys tell me what is the output of line number 29 and line number 30? Line number 29 and line number 30. 29, 30 output. In the same line you can tell. Both are false before overriding. Yes, exactly. You got the concept correctly. Very good. So that is the thing. We have not overridden, right? So if you run, everything will get false because of this reason. Yes. Are you seeing 4 falses here? Obviously, yes. But if you override, let me remove this. If you override, see, obviously equal to doesn't change. This equal to operator doesn't change. What we have to get to know here is this equal to also doesn't change, but the implementation has been changed. From the object class, this implementation has been changed. What implementation we changed? We have changed the implementation in such a way that two addresses of the two states or data of the two objects should be compared. See here, equals of same thing, addresses only is happening. Same thing, 0x1 dot equals of 0x2, 0x2 dot equals of 0x, the same thing is happening. But since we have overridden in such a way that we have to get the data compared to the object. You have to get the data compared to the object. So here, currently B1 and B2 doesn't have same data. So that we are getting false in line number 29. In line number 29, we'll be getting false because this B1 object Harry Potter, B2 object Java doesn't match. But here B2 object Java and B2 data, I mean B3 data Java. B2 object data Java and B3 object data Java both are same. Both are same. Since they are matching, since the data is matching, you already know string constant pool, string in string constant pool, right? Yes, true after overriding. Yes, correct. So here in the line number 30, you will be getting true. Why? Because the data of B2 and B3 are same. Data of B2 and B3 are same. Are you getting true here? Yes, you are getting true. You are getting true here. Okay. So this is why we'll go for overriding equals method. You guys got it, everyone? You guys got it? Completely understood two string and equals? Any doubts you have? You can let me know. Understood. Okay, guys. Okay, where is this? Okay, guys. Okay. So this is what we have seen. Yes, after don't see, you have to compare current object. See, current object with current object you can't take. You take in one hand. See, just imagine in one hand you take 5 chocolates. With that one hand, to whom you will compare? Can you compare to the same hand? You compare yourself. Assume you have 2 hands. Okay, you are having, you are comparing it with yourself. You are not comparing with others. Okay, repeat it once again. Okay, you'll see in a different program. Okay, see guys, the reason for downcasting is you have to go for current object with a past object. You in one hand you can take some chocolates and another hand you can take and you can compare. In one hand only you are taking and the same hand you are comparing. It will not work, guys. Without downcasting it's not possible. See, I will tell you here. One second. Means it is not possible in child class by upcasting, I asked. See, already it is upcasted. Already it is upcasted. Already it is there. Everything has been upcasted. We are not downcasting without upcasting. You'll get a class cast exception that time. Okay, we are already upcasting. We are already upcasting. Okay, so here, okay, what I'm about to tell is current object with a past object you have to match. Current object with a past object you have to compare. Current object with a current object only you can't compare. Current object with a current object you can't compare. So current object you can take it as a this dot a state, whatever the data is there. Next, whatever the object you have downcasted to variable b dot state. Now the two object address, I mean dot equals of whatever the data is there, you can compare. This dot state takes the currently executing object address and b dot states takes the next object address. Current object address and next object address. See, this you can tell b1 dot equals of b2. So this is b1. B1's current object. This is b2 past object. B1 is the current object. B1 is the current object. B2 is the past object. Two objects you take, compare. Data is same. Data is same. Ignore the objects addresses. Data is same. Equals method will return true. Only when the equals is overridden. When it is overridden in such a way that you will be comparing the data of two objects. Okay, this is what we'll be doing. Okay, so without downcasting it's not possible, guys. Already we have upcasted. Okay, like already it is there. If you don't want object you can take some other object. Okay, but here currently object class is used, standard way is to take object only. Okay, so if you're taking object, you're downcasting to book type. See, one book type object you are able to compare with another book type object. Okay, one book type object you're able to compare with another book type object. So here, see why you're downcasting is because already all classes are upcasted. Every child class is upcasted to object class. Every class extends object. Every class extends object. It will inherit. Yes, everything will be done. But here, see, Book class and object class you can't compare. Book is a different class and object is a different class. Both the classes you can't compare because it's a different classes. When you downcast book to object type, when you downcast book to object type, you will be getting a one more object with a type book, one more object with a type of book you will be getting. So current book with the past book name. Okay, current book name with the past book name we can check. Okay, so this is why we have to downcast. Okay, to take another object to a type of book, and same book type only we can compare. We can't take book type and object type and compare. We have to downcast book to object type, then you have to compare. Okay, so I hope you guys got it. Everybody understood? Okay, guys. Yes, where is she? Someone asked me to repeat. No, who is that? Hey, who asked me to repeat? Oh, who is that? I think Shivani. See, guys, you okay? Shivani Varma, you understood? Okay, so will Shivani, you got it? You are there here. Shivani, are you here? You got it? You were here or you exited? Shivani, I'm talking to you. Respond if I'm audible to you. Okay, guys, then we'll go further. Okay, so we'll go further with okay, one more example. So currently we have this class circle. So this is a previous example only. Circle 5 and 5 we have taken. Now what happens is, if you compare C1 dot equals of C2, since both data is same, equals method is not overridden currently. So C1 I mean dot equals of C2, it will compare the references only. It will compare the addresses only. So you'll be getting false. What you want to make it as a true, you have to excuse me, you have to override equals method. You have to override, yes, not downcasting is a part of overriding equals method. So what we have to do in order to compare the state or data, you have to override equals method. So here we are going for at the rate override. Okay, we'll be going for public return type is boolean equals method equals of object o equals of object o. So now what we'll do is we'll go for downcasting first. So circle c is equal to circle of o. Now we shall go for, see, there is one more way of doing it. I'll show you now. First way is return this dot c radius. Will go for this dot radius. Since see here, since radius okay, we'll go for equals only. Dot equals of c dot radius. Okay. See here, since we are using equals, okay, equals of int cannot invoke equals of int on a primitive type int. See here, ours is int, right? Int data we have. There we have we had a string. We had a string easily compared. We had a string easily we compared. Now it comes to int data. Now what is the problem here? When it comes to int data, what is the problem? The problem is you can't use equals for int. You can't use equals. See here, you're getting error, that is cannot invoke equals of int on the primitive type int. So equals accepts only object type. Equals accepts only object type. So what we have to do now is you can go for equal to equal to. Okay, you can go for equal to equal to. See, it will compare the radius with the radius. It will not compare the object address with the object address. Don't get confused. It will not compare object address with object address. It is comparing radius with radius. Here also it's fine. In this way also you can do. It is only for the numbers. For numbers you can use equal to operator here. Double equal to operator you can use. That is to only for numbers. Only for numbers. For string, okay. So suppose you can try to use it, okay. You can try to use it b1 dot equal to b2. So what will happen here? Obviously, you'll get false. So okay, better option is you can go for dot equals for the string. Remember, dot equals for string in a equals method. Okay, here for comparing bname dot equals. Since we are comparing bname LHS RHS, you can go for equals also. Here I should have not done. Yeah, here it's not possible. So because it's a equals here, because of this here method call statement. See, we are calling a method here. B1 dot equals of B2. Control is going and it's executing here. Okay, so equals of one data we are passing. See, this B2 and B3 is a past data. B1 and B2 is a current data, current object data. B2 and B3 is a past data. So it's going. You can usually use this equal to also. Okay, equal to also you can use. Let us execute here. Are you getting still true? Yes. Why? Because here we are comparing the data, direct data we are comparing. Like here we are not comparing the references. Like here we are not comparing the references. We are comparing the data. You can go for equal to also. You can go for dot equals also. Dot equals of b dot p. See, for a string, okay, for a string you can go for equals also, equal to operator also. For a string, remember carefully, for a string you can go for equals also and equal to operator also you can go for. But for a int you have to go only for equal to operator, because it's a primitive type. There is no address for primitive type. There is no address for primitive type. So for this dot radius equal to c dot radius, you have to go for equal to operator. For a string type data, for object type data, string type data, anything which has address, you can go for dot equals also, or you can go for equal to operator also. Both are fine. But if you are going for int or any primitive data type for that matter, any primitive data type you take, you have to go for equal to operator, because primitive members doesn't have address. Okay, primitive members doesn't have object address. Primitive members are not object. Primitive members are not object. Okay, so this is how you can do it. And now if you go for c1 dot equals of c2, c1 dot equals of c2, now let us execute. You have to get a true. Are getting true here? Yes, you are getting true. Okay, so if you try to use c1 equals to c2, okay, let us take this off. Yeah, now if you execute c1 equal to c2, what you get? Obviously false, because it's comparing the address. But if you go for c1 dot equals of c2 and you override equals method, and you override equals method, then you will be getting true, because the data of each object are same. Data of circle 1, I mean c1 is also 5 only, circle 2 is also 5 only. Okay, so this is about your toString and equals method. Okay, I hope you have understood. Everybody got the concept toString and equals? Everybody understood toString and equals? Do not forget this. Okay, hope you guys have understood. Anywhere, any doubts you can. Okay, got it. Okay, in case if you have not understood, you can let me know. We will use equal to for float, long to, like, yes, for all primitive data types use equal to operator. Only string is an object, right? String is an object, so you can go for dot equals to. dot equals in only overriding, only when overriding in the implementation you can go for equal to for primitive data types. But for dot equal, I mean for the object type you have to go for equals, and we can go for equals also, equal to also, operator also. These functions are only going to be used for reference objects. Reference objects. We are taking object data. There is nothing called as reference objects. What is this reference objects? These methods are you only going to be used for, yes, here we are taking address as y, I mean the reference variable y, because inside reference variable we have address. Okay, you can compare the whole two objects with address, because the whole object is stored in the reference variable c1, and this whole object address is everything is stored in the variable reference variable c2. So only we are comparing the reference. Got it, Sushant? Yes. Okay. Yes, Imanshu, got it. Please explain to string ones. Two string ones. Two string. Okay, we will do one more example. There I will explain you again. Okay. So we have taken circle. No, let us take one more example. We will take rectangle. Rectangle. Okay. So two attributes for rectangle. We can go for int length and int breadth. And one more thing, most of you gets confused here. Okay, let me tell you this again. Inside equals, second. See, for a primitive data type, if you're comparing primitive data type, inside equals implementation, you have to go only for equal to operator. But if you're going for non-primitive data, you can use equal to also, you can use equals method also. You can use equal to equals of for object. Since string is also object, for string you can use both equal to and equals. But for primitive data type, you have to only use equal to operator. Okay. So I hope you guys got it. Now let us do one more program for understanding this. Okay. Two string, to understand two string again. We'll go for your rectangle program. Okay, so we have a non-primitive variable that is, I mean non-static variables, this length and breadth. We'll go for constructor for the rectangle. Source. And now listen everyone, I'll just explain you the shortcuts how to create two string. Okay, later I'll explain for equals and one more method for hash code. Just currently listen to two string. So there is source. You can go for generate constructor using fields. You can see, right, generate constructor using fields. Click on it. Generate. You generated one constructor. Yes. Now you have to generate one two string also. You have to generate one two string also. Go to the same source. Above the constructor using field. About the generate constructors using fields. Above generate constructor using fields, you have an option called as generate two string. See, like we have generate getter and setter method. Okay, we can override and implement any methods. You can generate getter and setter methods. You can generate hash code and equals. So you can generate two string. Currently we know equals, we know two string. We will go for overriding two string. So here inherited method, we don't have to override from the object. Everything, if you just click here, everything will be overridden. But currently we just want the fields length and breadth to be overridden. So we'll generate it. Can you see here? Rectangle of length is equal to that much and breadth is equal to that much. So what are we getting here? As you can see now, okay, we have overridden two string by just calling it from the source. Rectangle, return. See, of rectangle of length is whatever length has been given. Breadth is whatever breadth we have given. Neatly you'll be getting this in output in this way. Okay. Now what we'll do is, let us go for your main method. Let us go for main method, and in the main method we shall go for creating an object for rectangle. Rectangle. Okay. Rectangle R1 is equal to new rectangle of, now we'll go for length. We shall go for maybe 35, some random length and breadth we can take whatever we want. So length we shall go for this, and breadth we shall go for 3, just a random data. Next we'll go for rectangle. R2 is equal to new rectangle of 44, length and breadth is 5. Okay, length and breadth whatever we want we can take. Okay. Next, after that we'll create one more rectangle object. Rectangle R3 is equal to new rectangle of, we shall, okay, so 2 are enough minimum, so 2 only is enough. Next, okay, now here, since we have to understand toString, okay, so why we have to go for toString? Mainly for this reason. Whenever we print the reference variable, we will be getting address, but here now we print the reference variable, we will be getting the output. Now you can see the output here. Can you see? You got the output. Rectangle length is equal to 35, breadth is equal to 3. Length is equal to 35, breadth is equal to 3. Okay, fine. Now we have just printed for R1. Now let us print for R2 also. We'll print R2 also. So for the second object also you will get the same output. Are you getting the same output? Rectangle of data, and here also rectangle of data. Are you guys getting it? Why we have to override toString? Yes, Sanket, are you getting here? We are overriding toString because if you don't override, when you're printing R1 and R2, you will get the addresses of the object. We don't want address of object because our Java is giving fake address and we can't do anything with it. So that is why if you don't override toString, if you're printing R1 and R2, you'll be getting addresses of the object. But if you are overriding and giving an implementation, whatever, however you want, you can give. Okay, by default if you are giving, you'll be getting like this toString. Okay, so we shall go for equals method now. Okay, we shall override equals method now. So at override we'll go for equals public boolean equals method equals of object O. Okay, now we shall go for downcasting. Rectangle R is equal to rectangle of address object reference O. Now we shall go for okay, see, there are two ways of doing it. We shall go for if else. Okay, we can go for if else also. Okay, listen carefully. One more way of doing it. We shall go for if else. So you can go for if this dot whatever, so breadth. Okay, this dot breadth is equal to r dot breadth. See, when we have two data and we have to compare at the same time, we can go for which operator. We have to compare two data, I mean two outputs we have to compare. Both are of boolean type. Whom we can use, which operator we can use, and or not, whom we can use. Both we have to compare at the same time. Whom we can use, and or not. Which one we can use, guys? Yes, we have to use and operator. So to compare both, we are using and. So this dot breadth is equal to r dot breadth. Next, this dot length equal to r dot length. Okay. So in case if this is correct, means you can return true. But in case if this is false, you can return This is one more way of doing it. Okay, this is one more way of doing it, that is in equals method. If current breadth object with the past breadth object, if it is not matching, it will return false. If one object or one data of the object only is not matching, obviously another one also don't have to check. We don't have to check another one also. So that is why we have gone for equals to, equal to operator. Okay, so if one data is different, okay, another data is also, we don't have to check. So that's why we have used AND operator. So breadth and length both should be matching. Then only we can return true. If it is not matching, okay, if it is not matching, we can go for returning false. We can go for returning false. Okay. So here now we shall go for comparing the uh, references. I mean using equals. So here, okay, we shall compare r1 dot. Here you have to use equals method only. Here you can't use equal to, okay. R1 dot equals of R2. Now R1 dot equals of R2. Now if you execute, you'll be getting false. Why? Because the data is different. Data is different. So only you are getting false. But if I create one more rectangle object with the same data, rectangle R3 is equal to new rectangle. So instead of doing this, we can go for one more way of also. One more way also. So we'll go for R2. What's happening here? The address of R2 I am storing inside R3. Since the data type is same, since R2 data type and R3 data type is same, since both are same, we will be storing the address of R2 inside R3. Address of R2 inside R3 we are storing. Address of R2 inside R3 we are storing it here. Okay, so this is how we'll be storing the whole address of one object into another object. This inside R3 currently you have all the details of rectangle R2. Now if you go for comparing, here both conditions will become true. So those are, if you are going for R2 equal to R3, will be getting true because both addresses are same, because both objects are same, both reference variable are pointing towards same object. In the concept of understanding reference variables, we have seen this. One object can be referred with n number of reference variable, but of same type. R2 is of rectangle type, so R3 we have given the address, so R3 also can be pointing to R2. Okay, so here equal to also they are getting true. And if you go for equals, that is R2 dot equals of R3. Now you'll be getting true only. Why you'll be getting true? Because here the data is also matching. When object address only is stored means obviously data is also matching. Data is also matching. Okay. So this is about equals method. Okay, this is about equals method. So, hope you have understood toString and equals. Next, we shall go for today's last method, that is hash code method. I'll just tell you what is the use of hash code. See, hash code is like extra, okay? It's like a additional validation you can do. See, return type is hash code is int. Okay, so what it will do is, see, equals method, if the suppose these two objects, okay, some two objects are there, okay, if these two objects are matching, suppose if these two objects are matching because of equals, suppose equals method like b1 equal to b2, if it is matching, so what happens is your hash code method will generate one hash code. That means one integer code it will generate. Integer code it will generate just integer numbers. You can just take it as a numbers. Okay, if equals is giving true for any object, if equals is giving true for any object, okay, when comparing two objects, if equals is giving true, hash code for that it will generate one unique integer number, one unique integer id it will generate. See, that thing hash code will do. work of hash code is. So earlier, without overriding, I'm telling now, without overriding, suppose you have four object address b1, b2, b3, b4. Listen carefully. We have not overridden hash code till now. For b1 object, it will create one unique hash code. Okay. And for b2 object, it will generate one unique hash code. For b3 object, it will generate one unique hash code without overriding, I'm telling. And for b4 object, it will generate one unique hash code. Okay. See here, for every different object, it will give one unique ID. Okay, it will give one unique ID. I'll show you now here. Listen carefully, everyone. Listen carefully. So if you're going for r1 dot hash code method, okay, and r2 dot hash code method, and r3 dot hash code method. See, these two objects are different. R1 and R2 are different, but R3, since R3 is pointing towards R2 only, R3 and R2 addresses will come same. Okay, R3 and R2 address will come same because these two reference variable are pointing towards one object. So what difference you'll find here? R1 and R2 will have two different integer numbers. Okay, R1 and R2 will have two different integer numbers. Can you see? R1 and R2 has two different integer numbers because they belong to two different objects. But here R2 and R3 are having same integer number because they belong to same object. So hash code method will generate a unique hash code number for every unique object. Hash code method will generate one unique hash code number for every unique object. But here after overriding hash code, what it will do? First of all, why we have to override hash code? See, we have to override hash code because we don't have to know, okay, if any single object is matching with address or not. Every object address, for every object it will give a unique integer ID. For hash code, before overriding, it doesn't matter. If you have same data of an object or not. No, it doesn't matter. But after overriding hash code, it will like equals. Hash code also will compare the data. It's like extra validation for equals. It is told that whenever you're overriding equals, you have to override hash code also. It will extra validate it. Okay, for extra validation only, we are going for hash code. Now let us see how to override hash code method. Okay, how can you override hash code? Next we'll see now. Okay, so we will go for overriding here. So at the annotation at override, public, and the return type is hash code is int. Okay, so int hash code method of no argument. Here you will be returning objects dot hash of, now whomever you want to compare, you can mention here. That is a rectangle, so we can go for length and breadth. See here, hash code. So hash code is a unique type here. Listen carefully. Based on only length it can compare. Based on only length and breadth it can compare. Okay, see, objects is a class present in util package. Can you see here? Import java.util. So what is it here? Import java.util.objects class. Java.util.objects class. Here we are importing objects class from the util package. Object class is different. Objects class is different. Object is different. Objects is different. Object is a class which is already inherited into the class because object is present in lang package. So compiler will inherit lang package members by default. But here we have objects class. This objects class uses here, current one uses, we have one hash method. It will compare how many ever attributes we mention here. No, based on that attributes it will compare all the objects. It will compare the all the objects based on length and breadth. Based on length and breadth, okay, it will compare. And for all those objects, if the data is same, see, the object, if r1 object and r2 object is a two different object, but if data is same, equals method will return true for that. Yes. Now hash code method also will generate one unique id for the data. hash code method Hash code method also generates one unique id for that data. Okay, so whoever objects are having same data, for that hash code will generate one unique id. So what I will do now, we'll go for one more object, that is rectangle r4 is equal to new rectangle of, here we'll go for 35 and we'll go for 3 here. So currently, if you're going for R4 hash code, also R4 is a different object. You'll be getting, see, R4. Let me execute here. Listen carefully. R4 dot hash code. Now you will be getting a unique integer ID here. You are also get a unique integer ID. Okay. So can you see here? Okay, you are getting. Okay, already we have overridden hash code. Just a minute. So now you'll be getting a unique ID. Can you see here? For this one unique id, and for these two same id, because those two references is pointing to one object, so this is one different id. Why we are getting? Because the objects references are same, they are different objects. Okay, since they are different objects, we are getting like this. Okay, now we don't want to see this hash code r1 dash hash code, r2 dash hash code. See, it is comparing, it's just generating one unique id for every object. Okay, for every object, for that means for every address it is generating one unique hash code. But when you have overridden hash code method, when you have overridden hash code method and told in the implementation that based on length and breadth you have to compare, based on length and breadth you have to compare, and you have to generate one unique id for the objects which is having same data. It will be behave as a, after overriding hash code will behave as a equals method only. Why? Because whoever objects are having same data, for them it will generate one unique id. Earlier what it used to do, for every, if every different object it used to create one unique id, integer id to create. But after overriding hash code, okay, but after overriding hash code, so what happens is this hash code will compare, now it will compare the data of all the objects. Okay, data for whomever we can compare here, it will compare the data of the objects here, and it will generate one unique id for every object which is having same data. Every object, it doesn't matter the whatever the object type, I mean the reference is, for every object, whoever objects are there, r1 r2 r3 r4, if the data is same of any objects, it will generate one unique id. So let us execute now. Okay, so you can see now here. Now everybody listen carefully here, don't leave the class, listen carefully. Now as you can see, R1 and R4 are having same data. Can you see? Line number 40 and line number 43 are having same data. So that is why 2049, you can get any integer number. It's not that you have to get 7 digits, 6 digits. No, you can get any digit depending on whatever data you have given. So here 2049 you got, 2049 you got. Why? Because R1 and R4 are having the same data. R1, since R1 and R4, since R1 and R4 are having same data here, since they're having same data, hash code has generated one unique id for them. Hash code has generated one unique id for them because the data is matching. And here R2 and R3, since they're pointing towards same object, obviously the data is also same. So when data is same, you're getting a unique integer id. You're getting unique integer id. Okay, so this is about your toString equals and hash code. Okay, so I hope everybody has understood. Everybody got the concept. Okay, so what about others? Everybody understood? No, ma'am. What happened, guys? You guys have doubt in hash code? You guys have doubt in hash code? Okay, you want me to explain now only? Okay, so here, okay, so what happens is, listen everyone. See, hash code, assume we are not overridden. Assume we have not overridden. So without overriding, if you print hash code for every reference variable, if you print hash code, since R1, see R2 and R3 are having same object address. R2 and R3 are having same object address. Okay. And here R1, R2, R3, R4. Here R1, and R4 are having a different object address. R1, R2 and R4 are having different object address. So that is why here you will be getting one unique ID. See here R1, R2, R4, they are different object. R2 and R3, they are having same object because R2 address is stored in R3. So these two are one object. These two are one object. Every object it's generating one. These two are one object, so it's giving same ID. Okay. So R1, R2, R3, same. R1 is different, R2, R3 is same, and R4 is different. For every object, it will give a unique integer ID. But after overriding, what equals method will do, it will compare the data. It will compare the data and it will return the unique ID, integer ID for the objects which is having same data. What compare will do? Compare will compare the data, right? Equals method will compare the data, right? Equals method will compare the data, right? Yes. In the same way, this hash code also will compare the data. Whichever object is having, okay, one second. Whichever object is having same address, for this 35.3, for this 35.3, that is for R1 and R4, now it will generate one unique ID. Why? Because the data of R1 and data of R4 are matching. Data of R1 and data of R4 are matching. Because it is matching here, it will generate one unique ID. So let us go here. Let us remove this. So if you go down now, see here R1 data and R4 data is same. Earlier, without overriding, these are four different objects. And R2 and R3 is same because they belongs to one object. R1, R2 and R4 are different objects. It didn't see what is the data, but after overriding, hash code method, after overriding, it will compare the data. So R1 and R4 are having same data. Okay, so that is why we are getting same one unique integer ID for, see, 2049 for R1, 2049 for R4. Why? R1 35 comma 3, R4 35 comma 3, they are having both data, same data they are having, R1 and R4. So only you are getting 2049 here and 2049 here. But here R2 and R3 belongs to same object. Since they belongs to same object, you are just getting the same integer number. That's it. One integer number will be given for one object. Since you're repeating it again, you just got it as a same. So for that, you will be getting yes, guys. I think I got network. I got disconnected. So okay, okay. Just wait a second. I have explained you guys. When you guys got offline, like when it was offline, how many minutes back? Can you tell me how many minutes back it was offline? 2 minutes. Okay. 1 second. I'll explain you hash code. Okay. Tomorrow I don't have to explain you guys. Toastring equals, Hash code, why we override? Because without overriding, first take hash code method, take every reference, see r1 dot hash code, r2 dot hash code, you will get a different id, different id for r1, different id for r2. Since r2 and r3 are pointing to same object, you will be getting same id for r2 and r3. And r4 is a different object because it has a one new keyword. So how many new keywords are there? That many different object, that is a unique integer id you will create. How many different objects are there? That many unique integer id you will create. But here, after overriding hash code, what it will do is it will see the data. R1 and R4 data is same. Yes, so since R1 and R4 data is same, it is giving same integer id for 2049 and 2049 for R1 and R4. Why it is giving same for R1 and R4? For R1 it is giving 2049, for R2 also it is giving 2049, because the address, I mean the data is same. R1 has a 35 in 3, R4 also has a 35 in 3. So it is giving one unique integer ID, that is 2049 and 2049. Since your R2 and R3 is pointing to same object, since your R2 and R3 is pointing to same object, for this new keyword, one more integer ID that has been given is your 2330. Since it is copied by R3, you are getting the same data again. Okay, same thing you are getting again here. Okay. Is it similar to two string difference? Is that gives output in the form of integer instead of true or false? Uh, no, there is no relation of two string here. There is no relation of two string. Two string is different. No. Two string is different. Hash code is different. See, to generate this unique integer ID, you have to override hash code in such a form that you have to just get the method, this hash method you have to get from the class objects. It's from the util package. It's from the util package. So here objects dot hash of, now if you want to compare only based on length you can take, but if you're comparing based on breadth you can take. Since we're in the constructor we have mentioned both, we are taking both. So for every object which is having same data, see length and breadth, if every it doesn't matter what is the reference, but if every object, if it is having same length and breadth, this hash code with the help of objects dot hash will generate one unique integer id. It will generate one unique integer id. Okay. Now because of that, since your r1 and r4 is having same data, see same length and breadth it is having, so it has given one unique id for r1 and r4. R2 and R3 belongs to same object, so one integer id only has been given. It has been repeating two times because we have printed two times here. Okay. So this is about your hash code method. Okay. I hope you guys have understood now. Everybody got it? Everybody understood? At least now? Okay, guys. Okay, guys. So that's it for today. Notes will be sent. Notes, portions, everything will be sent. Today, if possible, I'll send because there is a network issue also. I'll send it. Don't worry. Don't worry. I will send it. No problem. Because I had an issue with this one. I have been consulting. There was no response. So I've responded today. I've called. So yeah. So this is it. And I'll see you guys in tomorrow's class. Make sure you study, execute the code and come. Try different things. Come up with some doubts in case if you have. Okay. Yes, guys. That's it for today. Have a great evening. Take care, guys. Bye bye. Good night.